7063. The addition of power while in a vortex ring state produces an A. Increase of airspeed. B. Even greater rate of descent. C. Increase in cyclic control effectiveness. The correct answer is B. The vortex ring state, also known as settling with power, is a dangerous aerodynamic condition that can occur when a helicopter descends vertically or near vertically with a significant rate of descent while in a high-power setting. Even greater rate of descent when a helicopter is already in a vortex ring state. Adding power exacerbates the condition and leads to an even greater rate of descent. The increased power input creates a more intense vortex ring, which further hampers the rotor's ability to generate lift. As a result, the helicopter descends more rapidly, potentially leading to a loss of control and a dangerous situation. It is important for pilots to recognize the signs of a vortex ring state and understand that adding power will only worsen the situation. The proper recovery technique for a vortex ring state involves reducing collective pitch, increasing forward airspeed, and transitioning to a more efficient rotor state to regain lift and recover from the descent. 7064. Recovery from a vortex ring state should be initiated by A. Decreasing forward airspeed and or partially raising the collective pitch. B. Increasing forward airspeed and or partially lowering the collective pitch. C. Increasing forward airspeed and or partially raising the collective pitch. The correct answer is B. A vortex ring state, also known as settling with power, is a dangerous condition that can occur during helicopter descent. Increasing forward airspeed. One of the key steps to recover from a vortex ring state is to increase the helicopter's forward airspeed. By transitioning from a vertical or near vertical descent to a more horizontal flight path, the helicopter can escape the vortex ring and improve the airflow over the rotor blades. Increasing forward airspeed helps to break the cycle of descending airflow and allows the rotor to regain lift. Partially lowering the collective pitch. Lowering the collective pitch, which reduces the angle of attack of the rotor blades, is another critical action to recover from a vortex ring state. By reducing the pitch, the pilot decreases the rotor's lift and power demands, enabling the rotor to regain its efficiency and generate sufficient lift to overcome the rate of descent. It is important to note that both increasing forward airspeed and partially lowering the collective pitch are typically performed together to facilitate a more effective recovery from a vortex ring state. 7065. Under which situation is a helicopter most likely to enter the condition known as vortex ring state? A. While maintaining altitude with a forward airspeed of less than 10 miles per hour. B. While maintaining forward cruise airspeed with a rate of descent in excess of 300 feet per minute. C. While maintaining a forward airspeed of less than 10 miles per hour with a rate of descent in excess of 300 feet per minute. The correct answer is C. The vortex ring state, also known as settling with power, is a dangerous aerodynamic condition that can occur during helicopter descent. The specific situation in which a vortex ring state is most likely to occur: forward airspeed of less than 10 miles per hour. Flying at a very low forward airspeed significantly reduces the inflow velocity of air over the rotor blades. This decreases the effectiveness of the rotor system in generating lift, increasing the likelihood of encountering a vortex ring state. Rate of descent in excess of 300 feet per minute. Descending at a high rate, particularly in combination with the low forward airspeed, can exacerbate the vortex ring state. The high rate of descent creates a strong downwash of air, which interferes with the airflow over the rotor blades and disrupts the generation of lift. When both conditions are present, low forward airspeed and a high rate of descent, the helicopter is more susceptible to entering a vortex ring state. 7081. When making a slope landing, the cyclic pitch control should be used to A. Lower the downslope skid to the ground. B. Hold the upslope skid against the slope. C. Place the rotor disc parallel to the slope. The correct answer is B. During a slope landing, it is important to maintain control and stability on the sloping terrain. The purpose of using the cyclic pitch control: hold the upslope skid against the slope. The cyclic pitch control is used to adjust the pitch of the rotor blades and control the attitude of the helicopter. In a slope landing, the goal is to keep the upslope skid in contact with the slope while the downslope skid remains off the ground. By applying cyclic input, the pilot can tilt the helicopter's fuselage and use the upslope skid to maintain contact with the slope. This helps to prevent the helicopter from sliding or rolling downhill and ensure stability during the landing. By utilizing the cyclic pitch control to hold the upslope skid against the slope, the pilot can achieve a balanced and controlled slope landing. 7082. The steepness of the slope on which a helicopter with skid-type landing gear can land is most dependent on A. Its gross weight. B. The position of the CG. C. The amount of lateral cyclic travel available. The correct answer is C. When considering the landing capability of a helicopter on a slope, the primary factor: amount of lateral cyclic travel available. The lateral cyclic control allows the pilot to tilt the helicopter's rotor disc and adjust the helicopter's attitude laterally. The available lateral cyclic travel determines the maximum angle at which the helicopter can be tilted sideways, allowing the skid-type landing gear to maintain ground contact on a sloping surface. If the lateral cyclic travel is limited, the helicopter's ability to land on steeper slopes will be restricted.